Welcome to the Bodhi Academy. My name is Abhishek Lasso, and today we will continue with our chapter Light. So previously in this video, we saw that light always travels in a straight line. Now if you want to change the direction of light by using a mirror, that process is called or that phenomena is called as reflection of light. The object that appears behind the mirror is the image of the object formed by the mirror. When the size and the image distance from the mirror remain same, such an image is called as an erect image. When viewing an object in the mirror, the sides of the image are interchanged. So these all points we have discussed in the last class. So today we'll continue playing with spherical mirrors. Paheli and Bojo were waiting for their dinner. Bojo lifted a stainless steel plate and saw his image in it. Oh, this place acts as a plane mirror. Why is it so? Because it is any shiny surface can be used as a mirror. It can reflect light. My image is erect and is of the same size. So therefore it is a erect image. Paheli saw her image using the back of a steel spoon. Bujo, look here. I can also see my erect image, though it is smaller in the size. This spoon also acts as a mirror of some kind, said Paheli. So now when Bojo looked at himself in the plate, he looked at his image very erect and it was of the same size as him. But when Paheli looked, she also saw a erect image, but the size was a little smaller. You can also use a spoon or any curved shiny surface to see your image. Take a stainless steel spoon. Bring the outer side of the spoon near your face. Outer side region, which is the curved. The outer side is the curved region. Not the side where you scoop things, the outer side. Do you see your image? Is this image different from what you see in a plane mirror? Is this image erect? Is the size of the image same, smaller or larger? So is this image different? No, it is almost the same. But is this image erect? Yes, it is erect. But is the size of this image same? No, it is much smaller. Now you look at your image using the inner side of the spoon. Now you look at from this side, the inner side, the side which you use to scoop up things. So you look at yourself from that side. This time you may find that your image is erected and larger in size. So now what we are seeing here is that when we looked from the inner side of the steel spoon, we saw that our image was erected, as in now see this pen is like this, but when I will look at its reflection in the mirror, it will be like this. It will be turned upside down. So that means that image is erect and it will be larger in size. If you increase the distance of the spoon from your face, you may see your image inverted. So, okay, initially you will see it like this. But if you move it further, you might see your image inverted. That is, this pen, like how it turned upside down, you are going to see that phenomena. You can also compare the image of your pen or pencil instead of your face. The curved shiny surface of a spoon acts as a mirror. So now what they are saying is that the curved shiny surface, both the surface, not only the outer one but also the inner one, they act as mirror. So the most common example of a curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, it is called a concave mirror. If the reflecting surface, now if this is like this side, this outer portion which is coming out, such a mirror which has that bulging effect outside, such a mirror is called as a concave mirror. If the reflecting surface is convex, then it is called a convex mirror. Convex is the inner side of the spoon. So it is easier to remember. For convex, you remember the inner side of the spoon, and for concave, you remember the outer side of the spoon. The inner surface of a spoon acts like a concave mirror, while its outer surface acts as a convex mirror. Okay, so now we know that the image of an object formed by a plane mirror cannot be obtained on a screen. Let us investigate if it is also true for the image formed by a concave mirror. So now initially when we tried placing a screen between the object and the mirror, or even behind the mirror, we were not able to get the image of the object on any other screen. So now we'll see if it remains same for the concave and convex mirror. Take a concave mirror, hold it facing the sun. So they are saying you have to take a concave mirror, this, which is like this, like bent side, which is on the inner side of the spoon. You have to take that kind of mirror. You have to hold it facing the sun. Try to get the light reflected by the mirror on a sheet of paper. Adjust the distance of the paper until you get the sharp bright spot on it. Hold the mirror and sheet of paper steady for a few minutes. Does the paper start burning? Yes. So what happens is when you try to capture the sunlight or that ray of light onto that concave mirror, it will directly refract the beam of light onto the paper, and you will get a sharp beam of light that is coming, and that will start to burn the paper. This bright spot in fact the image of the sun. Notice that the image is formed on a screen. So now what they are saying is that bright spot that we could see on the paper, it is actually the sun. So we have finally got the image onto a screen, and real formed an image. An image formed on a screen is called a real image. Recollect that in activity 11.2, the image formed by a plane mirror could not be obtained on a screen. Such an image is called as virtual image. So, the image formed by a plane mirror that could not be obtained on a screen is called a virtual image. So any image that we are able to get on a screen, that is a real image. But any image that we are not able to get onto a screen, that is called as a virtual image. So now see what they have done here is fix a concave mirror on a stand. Any arrangement to keep the mirror steady would do, and place it on a table. Paste a piece of white paper on a cardboard sheet, say about 15 into 10 centimeter. This will act as the screen. So you have placed the mirror here, and here you have placed a screen. Keep a light candle on the table at a distance of about 50 centimeter from the mirror. So about 50 centimeter from the mirror, you keep a candle. Try to obtain the image of the flame on the screen. For this, you have to move the screen till the sharp image of the flame is obtained. Make sure that the screen does not obstruct the light from the candle falling on the image. Now, is the image real or virtual? Is it of the same size as the flame? So, if we get the image, then it is real. If we don't get, then it is virtual. Is the size of the flame same? Now, move the candle towards the mirror and place it at a different distance from it. In each case, try to obtain the image on the screen. Is it possible to obtain the image on the screen when the candle is too close to the mirror? No. In that case, you won't get. We can see that the image formed by a concave mirror can be smaller or larger in size than the object. The image may also be real or virtual. Concave mirrors are used for many purposes. You might have seen doctors using concave mirror for examining eyes, ears, nose and throat. Concave mirrors are also used by dentists to see an enlarged image of the teeth. The reflectors of torch, headlights of cars and scooters are made up of concave shape. So see, concave mirrors have multiple usage because they can give a real or they can give a real image. Also, they give a larger or a smaller image. So when you go to the dentist, they use this small mirror that they put inside to see. Actually, that is the concave mirror. In that, you can see enlarged image of your teeth. Bujo, see here you can see. This is the concave mirror that they use. So see, basically these teeth are small, but in the image you can see them quite big. So Bojo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and small in size. He wondered if the bell is also a kind of spherical mirror. Can you recognize this type of mirror? Note that the reflecting surface of the bell is convex. So yes, it is also a spherical mirror that is reflecting, and the nature of it is convex. Now repeat activity 11.7 now with the convex mirror. So initially we did that activity with a concave mirror. Now when we do with a convex mirror, we could see a real image at any distance from the object from the convex mirror. Did you get an image larger in size than the object? Can you now recognize the mirrors used as side mirrors in automobiles? These are convex mirrors. So now what they are saying is that the mirrors that are used in a bikes and all, they are the convex mirrors. So convex mirrors, they can form images of objects spread over a large area. So this helps the driver to see the traffic behind them. So now if we take a concave mirror, what happens is that I can see only myself. I won't be able to see what is besides me. But when you take a convex mirror, it covers more area around you. So therefore, in the bike mirrors, what will happen is you won't just see the bike that is right behind you, but you will also see many other that are followed by that another bike. So images formed by lenses. You might have seen a magnifying glass. It is used to read very small print. You might have also used it to observe the body parts of a cockroach or an earthworm. So the magnifying glass is actually a type of a lens. So we say that the magnifying glass we have all used. So it is used to see small objects. It basically gives you an enlarged image of it. So now this magnifying glass is basically a type of lens. So lenses are widely used in spectacles, telescopes and microscopes. Try to add a few more uses of lenses to this list. Get some lenses, touch and feel them. Can you find some difference just by touching? Those lenses which feel thicker in the middle than at the edges are convex lenses. So now what they are saying is that, see, one type of what they are saying is that the ones which are thicker in the center and then they thin out on the ends. These are convex. And the reverse of this will be the ones which are thinner on the center and broader at the ends. These are the concave lenses. Which feel thinner in the middle than the edges are concave lenses. Notice that the lenses are transparent and light can pass through them. Now, take a convex lens or a magnifying glass, put it on the path of sun rays. Place a sheet of paper as shown. See, as shown. Hold the lens and the paper in this position for a few minutes. Does the paper begin to burn? Yes. Now replace the convex lens with a concave lens. Do you see the bright spot on the paper this time too? Why are you not getting a bright spot this time? So when we used a convex lens, we got the bright spot. But when we replaced it with the concave lens, then we were not getting the bright spot. So why was this happening? We have seen in the case of mirrors that for different positions of object, the nature and size of the image changes. Is it also true for lens? Now, is it also happening in the lenses? Take a convex lens and fix it on a stand as you did in the concave, as you did with the concave mirror. Place it on a table. Place a lighted candle at a distance of about 50 cm from the lenses. Try to obtain the image of the candle on a paper screen placed on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is it real or virtual? Now vary the distance of the candle from the lens. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observations in 11.7 for the concave mirror. Now, Bojo is saying what? It means that we can see the image formed by a lens from the opposite side to that of the object. So, see here. Now, using a convex lens, what happened is, see, we have placed what we had done in the first case when we were using mirrors. We placed the mirror here behind the candle and the candle was in between. Now see, here we have placed the mirror between the candle and the screen and we have got a inverted image, right? And here when we place it, and here the image is much clear and it is almost of the same size. But when we placed it, when we got the mirror, when we got the lens closer to the candle, what has happened is the image has enlarged. See, even when you take the virtual image formed by a convex lens, in a convex lens you can see it is enlarged, and image formed by a concave lens, it is smaller. Did you get any position of the object and image which was erect and magnified? Yes. Could this image be obtained on a screen? Yes. Is the image real or virtual? It is virtual. This is how a convex lens is used as a magnifying glass. Now, sunlight is white or colored. Now, how do we know if sunlight is white or colored? We can see it as white light, but is it really white? Have you ever seen a rainbow in the sky? Yes. You might have noticed that it appears usually after a rain when the sun is low in the sky. The rainbow seen as a large arc in the sky with many colors. So we usually see rainbows when we don't see them on a sunny day. We see them right after it rains and there is slight sunlight that is there. In that case, we see an arc of colors called a rainbow. Many colors are present in the rainbow. So there are 7 colors and those are how we remember it with gear. Okay, Vibgyor. So we have violet, indigo, blue, green, yellow, orange and red. So these are the 7 colors that are present. When observed carefully, there are 7 colors in a rainbow. Though it may not be easy to distinguish all of them. So now when we see the rainbow, we don't see all the 7 colors. We see very few colors. Why it is very difficult to distinguish. These are red, orange, yellow, green, blue, indigo and violet. So you might have seen that when you blow soap bubbles, they appear colorful. So now when you blow a soap bubble, no, what happens is that you see colors. Why is that happening? Similarly, when light is reflected from a surface of a compact disk, you see many colors. You can see many colors here. On the basis of these experiences, could we say that sunlight is a mixture of different colors? Yes. So now what happens is that, see, sunlight is basically white. But the minute it hits a surface, it gives out many colors. So now take a prism. Allow a narrow beam of sunlight through a small hole in the window of a dark room to fall on the face of the prism. Let the light coming out on the other face of the prism fall on a white sheet of paper or a white wall. What do you observe? So we will firstly see all the 7 colors of the rainbow. This shows that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 different colors. Try to identify these colors and write their names in your notebook. Now see, another activity is take a circular cardboard disc of about 10 centimeter diameter. Divide this disc into 7 segments. Paint the 7 rainbow colors on these segments. You can also paste colored papers on these segments. Make a small hole at the center of the disc. Fix the disc loosely on the tip of a refill of a ball pen. Ensure that the disc rotates freely. Rotate the disc in a daylight. When the disc is rotated fast, the colors get mixed together and the disc appears whitish. So they have taken a pen tip and they have taken a round cardboard which has all the 7 colors of the rainbow. So what they are saying is you take it and you take it in sunlight and you twist it very fast. when you are twisting it very fast and the sunlight is falling on it, you will see that all the colors mix together to form white. Such a disk is popularly known as the Newton's disk. So this disk is known as Newton's disk. So that was it for this chapter. So what we have learned here is that firstly, light travels along straight lines. Any polished or a shiny surface acts as a mirror. An image which can be obtained on a screen, it is called a real image. An image which cannot be obtained on a screen, it is called a virtual image. The image formed by a plane mirror is always erect. It is virtual and is of the same size of the object. The image is at the same distance behind the mirror as the object is in front of it. In an image formed by a mirror, the left side of the object is seen on the right side of the image and the right side of the object is seen on the left side of the image. A concave mirror can form a real and inverted image when the object is placed very close to the mirror. The image formed is virtual, erect and magnified. The image formed by a convex mirror is erect, virtual and it is smaller in size than the object. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image form is virtual, erect and magnified. When used to see objects magnified, the convex lens is called a magnifying glass. A concave lens forms erect, virtual and small image than the object. White light is composed of 7 colors. So that was it for today's video. Please don't forget to like, share and subscribe to the Modi Academy. Thank you.